Stability of nucleus. Stability of nucleus depend upon nucleon number. Nucleon number means that is a number of protons and a number of neutrons. And here we have one of the point that is about nucleon number. Suppose if you have nucleon number, that is proton number and neutron number at even number, those are more stable when compared to which are having odd numbers. For example, He24, C612 and oxygen 816 are having, you see, even number of protons and even number of neutrons are there. But lithium 36 and N714 and F918 are having odd number of protons and odd number of neutrons also. 18 minus 9, 14 minus 7, 6 minus 3. Odd number of neutrons and odd number of protons. So when compared to these elements, these are little stable. Now see with one example, Na sodium 1123 and Na 1124 isotopes, same atomic number, different mass number is there. Here how many number of protons are there? Proton number is 11 and neutron number, that is A minus J, 23 minus 11, that you can write 12 here. And in this case, in second nuclei, what you can write, Z is equal to 11 and N is equal to 24 minus 11, it is 13. So this you see odd number, and this is odd and this is even. And here this is odd number and this also odd. You see both are odd, and here one is odd, another is even. So in these elements, in these two nucleus, which is having better stability, means this has better stability. Reason, at least one of the nucleons is having even number. This has even number, and these both are odd. So that's why this is little stable. See another example, and zinc 3065 and zinc 3066 is there. What is the number of protons? 30. And what is number of neutrons? That is 35. Number of neutrons represented with N, 35. And here number of protons in this element 30, and number of neutrons 66 minus 30, that is 36 number of neutrons are there. This is a even number, this is odd number, and this is a even, and this is even. In this, which is better, having better stability means this, but because both are even number, here one is even, other is odd. So this is a better stability, has a better stability. From this, what you can say, which is having the elements which are having and both even number of protons and even number of neutrons, those are more stable. And after that, either one is even, other is odd, or odd or even, both are similar type only. These two are similar type. And after that, odd and odd, this has less stability when compared to this. This is the order. First, even and even, this is a more stable. Then these two, any one is odd, any one is even, that is having less stability. And the third one is both are odd, means it has less stability when compared to these two cases. And the elements which are having proton number 2, 8, 20, 28, 50, 82, 26, these elements are more stable when compared to other elements. That's why these elements which are having and number, atomic number or mass number, proton number 2, 8, 20, 28, 50, 82, 26, 126 are called magic numbers, because these elements have more stable. For explanation of stability of nucleus, we have one graph. How they are drawing this graph means they took proton number, that is atomic number, on z-axis and neutron number on y-axis, A minus Z on y-axis. For different elements, they put we have different elements, that is hydrogen and deuterium, tritium, helium, oxygen. For these all elements, where you get points, they are noted here. For example, you can take a krypton here, 36 and 89 is there. Suppose krypton 36 and 89. And 36 means somewhere here. 36 between 40 and 30, somewhere here. and 89 minus, what is the number of neutrons here? 53. So 36 and 53, here 36 and somewhere here 53, somewhere you get here a point. Similarly, and barium 56 and 144, number of neutrons are 88. In that case 56 and 88 we have to mark. 56 between 50 to 60, somewhere here is a 56 and 88 somewhere here. So these two, where they add, there you have to take the point. Like that for all the elements, and we have total 900 elements are there. 900 elements are there, but all these 900 elements are not stable. But we are only finding these many elements. Only around 200 elements only exist in nature, and remaining elements also there, but those are not stable. That's why we find only these elements. These elements, if you observe, only these all dots are representing those elements. And if you want to build a element which is having, for example, you can take a proton number 50, and if you want a neutron number 130, you can build here. But it is not stable. It is not stable for a long time. Immediately it will convert into stable nucleus. Immediately it will go into these regions. In this region, they show here red dots and black dots. You know what is red dot showing means, and a line is like this, means more number of protons, and black dot shows that more number of neutrons. If somewhere a point is here, we can say a huge number of protons are dominating here. If the dot is somewhere here, huge number of protons are dominating. Then what happens? Suppose if you take an element here, immediately it loses its protons, convert into neutrons, it goes into this region to get stability. Similarly, here is there a number of neutrons are dominating, and neutrons are convert into protons, and those also convert into a stable nucleus here. This line you see, a blue color line, it is not a straight line, but it shows the stability line. So all the elements are tried to convert into stable element. Unstable nucleus are convert into stable nucleus. That process what we call decay. By decay, and it can convert a unstable nucleus can convert into stable nucleus. You see this here, one line is there, that is n equal to z. N by z is equal to 1. That means on this line number of protons and number of neutrons are equal. And for some elements, suppose below 20, if you observe He24, 2 protons, 2 neutrons, and N714, 7 protons, 7 neutrons, and oxygen 816, 8 protons and 8 neutrons, like that is there. Equal number is there. That means initially this line, the stable line, follows the n equal to z line. N by z is equal to 1 line, because both are equal. Proton number and neutron number equal. But whenever atomic number increases, the neutron number start dominating. Neutron number increases. The elements which are in this region and neutrons are converted into protons. So by converting neutrons into proton, what happened? Neutron number decreases, proton number increases. That's why what happened? It shifted to this line and this region. In this region, all the elements are more stable when compared to elements this side and below this side. So how these neutrons are converted into proton and how protons are converted into neutron, that we'll see now. A neutron convert into proton, and here we get an electron outside along with an anti-neutrino we get. And proton convert into neutron, what happen? You get a positron. Here you get a positron, E plus 1, 0, and you get a neutrino. What is this neutrino means here? Suppose in this nuclear reaction, the neutron convert into proton or proton convert into neutron. If initially this neutron and proton are at rest, and after forming proton and electron, law of conservation of momentum must followed by these two particles. But in this reaction, it is not following law of conservation of momentum. Thus why they decide that another particle also there to provide law of conservation of momenta, that they assume as a neutrino. This is here anti-neutrino. Same thing here, to follow law of conservation of momentum, they assume one particle called neutrino. Like this, neutrons are converted into protons and protons are converted into neutrons. And those are elements which are having high number of neutrons, and losing their neutrons converting into protons, they get stability, and protons converting into neutrons which are having elements high number of protons, losing their protons and gaining neutrons, and those are converted into stable nucleus. That means these black dots are representing domination of neutrons. They lose neutrons and comes to the stable line. And red dot shows domination of protons and lose protons and goes to that. When proton decreases means what happens? Neutron number increases. So it goes into stable line. But the elements which are having higher atomic number, 92, 100 like that, those are, there is no, not at all, there is no here stable line. All the elements are try to always convert into medium sized particles and try to convert like this. In this region they are moving between 52 and some value between 50 to 80 they are try to convert. Here important points: the elements which are in this region, in this shaded, this total region, those are stable elements. Above this or below this any element is there that immediately decays, means it will be disintegrate and convert into stable nucleus. The elements which are having even number of protons and neutrons are more stable when compared to other elements. And by losing neutrons, the elements which are converted into stable elements, here by losing protons, those are converted into stable elements. Some of the elements are having n equal to z line. That means some of the elements up to atomic number 20 and proton number, neutron number almost same is there. So those are on this line, n is equal to z line. That is about stability of nucleus.